This is Finite Math, Chapter 5, Section 1, Simple Interest and Discount. First of all, interest is a fee that is paid to use someone else's money. It could be a fee that you are paying to borrow money from the bank and use their money. It could be a fee they are paying you in order to have you deposit your money with them and be able to use it for their investments. Simple interest is interest that is paid generally on loans of 1 year or less, and it's only calculated on the amount borrowed and not on previously accumulated interest. The amount borrowed is called the principal. The rate is given as a percent per year, and it does need to be converted from a percent to a decimal before using it in calculations. And the time is always calculated in years. Our simple interest formula should be a familiar one. I equals PRT, interest equals principal times rate times time. Let's try an example. We have Maggie borrowing $4,000 at 3% interest for 9 months. Pause this recording and see if you can figure out how much interest she will pay. Resume the recording to check your answer. Using this simple interest formula with P equal to 4,000, R equals 0.03, and T is 9 over 12, which reduces to 3/4, we get that she's going to be paying her parents $90 interest. Next, we're going to talk about bonds. We said that simple interest is generally for loans that are of 1 year or less. Bonds tend to break that rule. Typically, they pay simple interest twice a year for a set number of years, and then when the bond matures at the end of that set number of years, you are repaid the initial investment. So for example, we have Bank of America issuing a 10-year bond at an annual simple interest rate of 3.3% paid twice a year. How much interest will John earn on a $10,000 bond every 6 months? And then how much will that be over the 10-year life of the bond? Pause the recording, see if you can do the problem, and then resume the recording to check your answer. Okay, just put the numbers into your simple interest formula. Principal is $10,000, the rate is 0.033, and the time is 1/2 because it's every 6 months or half a year. Multiplying these numbers together, we find that he is going to receive $165 every 6 months. Now, how much does that mean he will receive over the 10-year life of the bond? There's 2 ways you can do this. One is to go back to your simple interest formula and instead of 1/2 for time, put in 10. When we do that, we get $3,300. Another way of looking at it is if he gets paid every 6 months for 10 years, he will receive a total of 20 payments. So take the $165, which would be one payment, and multiply it by 20. You get $3,300 using this method also. The future value is the value of the investment at maturity. It's the combination of principal and interest. To get our formula, we start with that basic idea. The amount is principal plus interest. And then we replace interest with principal times rate times time, because that is the simple interest formula. Notice that both terms of this expression have a p, so we're going to use a little algebra and we're going to factor out the p, and that will give us our final formula that the future value of the investment is the principal times the quantity 1 plus rate times time. Let's try an example. Rick borrows $20,000 at 5.25% interest. He plans to repay in 9 months. What is the maturity value? In other words, what does he pay at the end of that time? And how much of that is interest? Pause the recording, give the problem a try, and then resume the recording to check your answer. Okay, putting our numbers in, the principal is $20,000, the rate is 0.0525. The time is 9 months, so 9 over 12. Put those numbers in, which is 3/4, so 0.75. Put those numbers in the formula, and you find that at the end of the time period, he is paying his parents $20,787.50. To figure out how much of that is actual interest, subtract his original amount that he borrowed from that. So you're going to subtract $20,000 from that, and you're going to get $787.50. Try this similar example. Pause the recording to give it a try. Resume the recording to check your answer. Pretty much what we just did, just different numbers this time. Notice that for time, it's going to be 85 out of 365. Sometimes they will tell you to use a different number for the number of days in the year, like maybe 360. But unless they give you a specific instruction like that, assume that there are 365 days in the year. Putting the numbers into our formula, we find that the total amount at the end is $11,516.42. And then subtracting the amount of the loan, we find that $236.42 of that was interest. Here's another example. You're going to borrow $15,000. You have to pay $15,315 in 4 months, and that is the loan plus interest. What is the rate? So we're turning our formula upside down a little bit here. Pause the recording, give the problem a try, and resume the recording to check your answer. Okay, so what we did was we just put all our numbers in. This time we're missing R, and then we use some algebra to solve for R. Once we've done that, we find that R is 0.063 or 6.3%. Now we've been talking about future value, what the loan is worth at the end. Now we're going to talk about present value, and that's how much is it worth right now. The present value is the amount you need to deposit today to get a given amount in the future. To find the formula, what you do is you take the future value formula, the one we just looked at, and you solve for P. And when you do that, this is what you get. The present value is the future value divided by the quantity of 1 plus rate times time. Let's try an example using the present value formula. Find the present value of $32,000 in 4 months at 9% interest. Pause the recording, give the problem a try, and resume the recording to check your answer. Here's our solution. All you have to do is put the numbers into the formula. Remember that 4 months is 4/12 of a year. And when you do that, you find that you have $31,067.96. In other words, if you were to put this amount in an account that pays 9% interest in 4 months, you would have $32,000. In this example, we have 2 men, Jeff and Chuck. Jeff owes $5,000 to Chuck, and he must pay it in 10 months with no interest. But Jeff wants to pay the money today, and Chuck knows that he can invest that money today at an annual rate of 5%. What amount should he be willing to accept to settle the debt? In other words, what amount does Jeff need to give him so that in 10 months in this account, it will become $5,000? Give this problem a try, pause the recording, and then resume the recording to check your answer. And here's the solution. We want to know what it's worth now if it's going to be worth $5,000 in 10 months. So amount is 5,000, rate is 0.05, time is 10 out of 12 or 5/6. Putting these numbers in, we find that Jeff should be able to give Chuck $4,800 today to pay off his $5,000 debt. This time we have Larry owing $6,500 to Virginia. It's payable in 1 year, and the interest rate is 6%. Virginia needs money to pay medical bills. So 4 months before the loan is due, she sells the note to the bank. The bank wants a return of 9% on its investment. How much should it pay her for the note? Give this problem a try, pause the recording to do that, and then resume the recording to check your answer. The first thing we need to do is to find out how much the loan is worth when it comes due. So we're going to put it into our interest formula. And we find out that it's going to be worth $6,890 when it matures. Now in 4 months, the bank is going to receive that money. Since the bank wants a 9% return on its investment on what it is giving to Virginia, we need to figure out the present value of this amount, because that's what the bank will give her at 9% for 4 months. So we're going to use our present value formula. We're going to take $6,890, that's what the loan is going to be worth in the 4 months. On the bottom, we're going to have 1 plus rate, which is 0.09, 9%, times time. The bank won't be able to collect for 4 months, so 4 out of 12. And we get $6,689.32. So in giving her that, they will have made 9% back in the 4 months on that money by getting the $6,890. Now we're going to talk about discount. And a simple discount loan is a type of loan where the interest is deducted from the loan up front. The borrower receives the balance. And then at the end of the term, when the loan matures, you pay the entire amount. U.S. Treasury bills are handled this way. They have a face value, but you pay less than that. The interest is deducted up front, so when you buy them, you're paying less than what they actually say on the front, and less than what you will be receiving when they mature. In this type of loan, the amount borrowed is the future value. The amount the borrower receives is the present value. So here's an example. We have an investor who bought a 6-month $8,000 Treasury bill. It was sold at a discount rate of 0.135%. What is the amount of the discount and what is the price of the bill? And see if you can solve this problem. Pause the recording and then resume the recording to check your answer. Okay, we've said that this is a simple interest problem, so we're going to put this into there. The principal is $8,000. The rate is 0.00135. And the time is 1/2, 0.5, because 6 months is half a year. And we find that the interest on $8,000 is $5.40. What that means is that you will pay $5.40 less than $8,000 for this Treasury bill. So to find the price, you take the $8,000, subtract the interest, you get $7,994.60. Okay, now we're going to find the actual interest rate paid by the Treasury in example 8. Pause this recording, see if you can do the problem, and resume the recording to check your answer. Okay, again, we're going to use the simple interest formula. We know the interest already. We figured out that it was $5.40. The principal is going to be $7,994.60, what we pay for the bill. And the time we know is half a year, 6 months, so time is 0.5. But this time we want to know the rate. So we put all that information into our formula and solve for R, and we get 0.00013509, or 0.13509%. Right, this is just a formula summary. This is all the formulas on one page. What we've talked about in this section has been simple interest, the future value, and the present value. Remember, you do have these formulas on the formula sheet, which is available on my website. The rest of these problems are classwork problems that we did to make sure we understood the problems in class. If you want to go back over these, what I suggest you do is pause the recording, try the problems, then resume the recording to check your answers, and just continue to do that until the presentation ends. Pause to try the problem. Again, pause to try the problem.